Hello everyone, welcome to the video lecture series 1 on DC electric circuits. So I'm Sajita, so let us deep dive into resistance in series as well as parallel circuits. As we all know, resistance is nothing but the opposition to the flow of current. And let us see the behavior of the resistance in DC circuits while it is connected in series as well as in parallel. So moving to the next slide or moving into the next part of it, I just have a question for you. So how do you think that a resistance or what is the unit of the resistance? Yes, it is ohms. So now we'll clearly see what are all the objectives of this series. So at the end of the lesson, you should be able to calculate the combined resistance of two or more resistors in series and calculate the combined resistance of two or more resistors in parallel. So coming to the electric circuits, it can generally be classified into two categories. So one is series circuits and the next one is the parallel circuits. So let us go deeper into the resistor arrangement in an electric circuit. Specifically, this is going to be the DC electric circuits. So resistors and resistance. So there should be a clear demarcation between what a resistor is and what is resistance. So this question I am putting it to you all. So resistance can be connected in parallel, also in series. So resistors are the physical form where you can see the element, and resistance is the opposition offered by it. So you can see the circuit of or the series of resistors which are connected, and you can also see the resistors which are connected in parallel. That is, connecting one after one is called as series, where the one terminal of the resistor and the other terminal of the other resistor is connected. Whereas in parallel connection, all the terminals are connected to the same point, and that is called as the parallel connection. This is similar for every other components also, not only in resistors, but also for the other components too. So coming to resistors in series. So as we have seen the circuit here, let us assume that there are three resistors R1, R2 and R3, and they are connected in series. So you can clearly see here one terminal of resistor R1 is connected to the other terminal of resistor R2. Likewise R2 and R3. Now the total resistance when considering here is nothing but the effective resistance or the resultant resistance, which is equal to the sum of the individual resistance. So you can see the total effective resistance and its formula here, which is nothing but R total is equal to R1 plus R2 plus R3, just the summation of the number of resistors connected in series. So let us just assume a scenario where there are 5 resistors, say R1, R2, R3, R4 as well as R5. So what is going to be the total resistance here? Yes, the total resistance is nothing but the summation of all the 5 resistors. We can say it as starting from R1 till R5. So R1 plus R2 plus R3 plus R4 up to R5. Let us assume that there are Rn resistors. So what is going to be the total resistance in series? Yes, it is R total is equal to R1 plus R2 up to Rn. So now imagine the resistors are connected in parallel. As you can see in the circuit, R1, R2 and R3 are connected in parallel, and here the total resistance or the effective resistance or the resultant resistance is equal to the sum of the reciprocal of the individual resistance. In series we saw that directly the resistance can be summed, whereas here it is reciprocal of the individual resistance. So 1 by R total is equal to 1 by R1 plus 1 by R2 etc. up to 1 by R3. Also, let us assume that there are n resistors in parallel starting from R1. So the total resistance is going to be 1 by R total is equal to 1 by R1 plus 1 by R2 etc. up to 1 by R. If two resistors R1, if two resistors of resistance R1 and R2 are connected in parallel, the total effective resistance is similar than the R1 and R2. So here I1 and I2 is the total current and it is given as flowing through the resistance R1 and R2. So the total effective resistance is 1 by R1 plus 1 by R2, which can be simplified as R1 R2 by R1 plus R2. So let us discuss about the upcoming sessions in the next video lecture series. So thank you for now.